Okay, so we are on page 125. And I want you to write something on the top of the workbook pages, okay? I'll show you what I mean. My projector turning on yet, guys? Behind me? Okay, good. So over here on 125, I have you take a little bit of notes to acknowledge what type of model it is. If you can please write on this side where it has the little groupings like this, where they're all in different little pods. I want you to write the title, whole number groupings. Just write that for me. This is the whole numbers groupings model. And this one over here on this side is called fraction of fraction. Fraction of a fraction, right over here. Everyone have that? So you can see by the way that the drawing is created, whole number groupings means that you have separate little drawings that represent multiple copies of the same grouping, right? So how many copies of this grouping do you have? How many copies of it? 1, 2, 3, 4. There's 4 copies of one fraction. What fraction did they model in the first little drawing here? What fraction is this? Tell me what fraction this is. What fraction is this? 2/3. So there's 4 of those, right? There's 4 copies of 2/3. Everyone put your finger on the expression here on the bottom and say 4 copies of, are you pointing to the time symbol when you say of? Go back to the beginning. 4 copies of 2/3 is equal to 8/3. Wait, let's check that. 1, 3, 4, 5, 6, 7, 8. Yep, there's 8 of them. Why is it called 8/3 and not just 8?
Because there's 8 and then because you have to add.
Stop talking like that. Both of you. There's 8 of them, yes. But why did I call them thirds? And not just 8? What do you think?
You have to keep the denominator.
Okay, so each of these pieces that I'm counting is worth what? 1 what? 1/3. So if there's 8 of those thirds, then I call it 8/3. So this piece right here, can you draw a little line on it and label it like this? This piece is worth 1/3. And this piece is worth what? 1/3. And this piece is worth 1/3. So if there's 8 of them, then altogether, I don't say there's 8 pieces, I say there are 8/3. Wow, that mouse is being friendly today. 8/3, which you should be saying improper fraction alert, improper fraction alert, and then what? You have to divide in order to say, well, how many wholes does that represent? And what's the remaining leftovers, right? So this is how you converted into 2 2/3 by dividing. How many times does 3 fit into 8? 2 whole times with how many leftovers? 2/3 left over. Whole number groupings aren't bad. What numbers on the rest of page 125 are whole number groupings? Is number 1 a whole number grouping? Yes. What other numbers are whole number groupings?
5 and 9.
Okay. So if you can identify which model is a whole number grouping, that's really good. Now let's talk about fraction of fraction. So fraction of fraction is demonstrated on one whole because it's a part of a number. And so when you're taking part of a number, it's sort of you're setting aside a part of it and then taking only a part of the part you set aside. So you're going to represent it by an overlap and shading. So whichever part is overlapping, that's the part that represents the answer, the solution to the problem. So if you can look over at this piece that has both the green and the lines, that would represent the answer. That's the fraction of the fraction. That's the part of the part. And I have a better model that I want to share with you. Could you just hold your question for just a second, Esther? Okay, I have this better tool that I wanted to use. Everyone can see this? All right, so what this whole represents is 30 parts. So in order for it to be called one whole, how many would have to be colored altogether? 30, right? But we're going to be showing what a part of a part looks like. If it will let me click, it will not let me click. What's going on here? Come on. Oh, I guess I have to do it in this mode. So here's part of a part. I'm going to pull this into the middle here. What do you notice about the pieces that are overlapping? Are they a different color?
Yeah.
So it's like yellow is overlapping with the blue. And what part do they make when they're overlapping? What color? Green. Green. So how many pieces are overlapping, boys and girls? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of how many parts altogether? 10 out of 30. So 10 out of 30 would be the answer to 5/6 times 2/5 would be 10/30ths, which we know we could reduce to 1/3. But okay, let me get a couple more fractions in here. What would, here, let's get this one out. And I added this to the Google Classroom in case you wanted to play around with it. But what would 1/6 times 3/5 be? What would the answer be? 3 what? 3/30ths, because 3 of the sections are shaded with both colors out of a total of 30 parts. Okay, let's do another one here. What would this one be?
30 parts.
I counted those squares in the background. All right, what's the answer to 2/6 times 3/5?
6/30ths.
6/30ths, because 6 out of the 30 are shaded. Okay, let me get another one in here. What do you think when I put 1/5 down? 1/5 times 1/6 going to be? What's the answer going to be?
1/30th.
1/30th. Is this visual easier for us to understand?
A little bit.
Yeah, okay. 4/5 times 2/6, what would it be?
8/30ths.
Do we see the green overlap, boys and girls? Okay. So I want you to look now at what we have on our workbook page and look at the model again. They're using, instead of yellows and blues, they're using maybe different shading techniques like lines and solid. So look at this. This represents 1/4 because it's 1 out of 4 slices going this way. But then try to look at the rectangle going the opposite direction. See how 2 out of the 3 are shaded? Yeah? So how many pieces altogether are shaded with both the solid and the lines? 2 out of how many parts are all together there? 2/12, right? There's 12 pieces altogether. So we can reduce 2/12 to be 1/6. So let's look now down the page. And what I want us to do first is label each of the problems. Are there 9 here total? Okay, cool. I want to label each problem either whole number grouping or face fraction to fraction. So what would number 1 be? Whole number grouping or fraction to fraction? So everyone just write like WG for whole number grouping. What about number 2? Fraction of fraction. So everyone write FF. How about number 3? Maybe I can write down here today. Let's see. Fraction of fraction. Number 4, whole number grouping or fraction of fraction. Fraction of fraction. Number 5, whole number grouping or fraction of fraction. Whole number grouping, good. Number 6, fraction of fraction. Are you writing this on your workbook, everyone? Number 7, we're going to go back and do the answers in just a minute, but I like when you recognize what type of problem you're dealing with first. How about number 9? Whole number groupings, because there's more than one copy of the same fraction. So when there's whole number groupings, it's like you had one fraction and then you multiplied it times a whole number. So you have many copies of it. Okay, let's go back. Esther, have I answered your question yet, or do you have it now? Would be a good time.
Yes, I was going to say, are we going to be cross multiplying?
No, we're just demonstrating modeling today. And you might already know the answer to some of these just by figuring out some cross multiplying or some techniques. But we're working on conceptual like understanding of what happens when we multiply fractions. This is like a visual approach before we go into the procedure and all the rules about it, okay?
Okay.
So when I look at number 1, I can see how many groupings, guys? I can see 3 groupings. That's why they put the number 3 here. There's 3 groupings of what? Of 4/5, right? So look at this phrase, and from left to right, you should be able to say 3 groupings of 4/5. Do you know that that word of is actually a multiplication word? Did you know the word of? So when you hear the word of, you know multiplication is going on. 3 groupings of 4/5. That's what we have here. How many groupings are there, Ryan? 3. Okay, that's why there's a 3 here. Of means to multiply, right? That's why we are using that symbol. And 4/5 represents what do we have 3 copies of? We have 3 copies of what fraction? 4/5. So we have 3 copies of 4/5. So the answer would be, how many fifths is that? We would have to say, well, this piece is worth 1/5. How many green pieces do I have all together now? 4, 8, 12. 12 what? I have 12 pieces, but they're each worth a fifth. So I have 12 fifths. Improper fraction alert. So what do I do? 12 divided by 5. You might be able to start doing this in your head. What's 12 divided by 5? 2. It's going to be 2 whole. That would be 10. So if 10 were how many times it went evenly? What's the difference between 10 and 12? 2. So that means my remainder is going to be 2 out of 5. 2/5. Meaning, so this is what it means, Ryan. If I picked up one piece from here and filled it up to be 1 whole, picked up another piece and filled that one up to be another whole, I'd have 2 wholes and how many leftovers?
5.
I would have only 2 green ones left over. And that would represent 2 and 2/5. 2 and 2/5. Just think about it as pieces of pizza getting put into a box to fill it up to make a whole. It would be a lot easier if we could use some manipulatives today and then physically rearrange the way that they look. Yes, Carter?
What happens to that 3?
Well, the 3 is just showing how many groupings that you have. Now, when we go and do the rule tomorrow, watch how I change this into a fraction. Isn't 3 the same as 3 over 1? Watch. What's 3 times 4? 12.
12.
What's 1 times 5?
5.
That's how we're going to find the answer tomorrow. That's how we're going to find the answer tomorrow.
Literally how you.
You're just going to multiply straight across.
That's exactly how I do. That's exactly how I look at the.
And that's why I said addition subtraction is so much harder, because in addition and subtraction, what do you need? Common denominators, right? And you don't. With multiplication and division, you don't need common denominators. You just multiply straight across.
It's exactly right.
Isn't that easy? But today we're doing, so just tell me what the answer is going to be here. It's going to be 3 over what? 12. That's what the answer is going to be. Now prove it to yourself. Look at the model. Look at the model. How many are shaded with both colors? 3 out of what? 3 out of 12.
All we have to do.
That's all we're doing it.
So
we reduce it to 1/4.
Or you could give us the whole page.
Okay, don't get too confident just yet. Hang on. Hang on.
Don't push it.
Because I reduced it by a factor of 3. I divided the top.
Just don't get us more.
How many are colored with both shades? Look at. These are both colors. It might be hard
I
to
know,
see
but
on the
there's
board.
one extra on the corner.
Yeah, but that one's not with both. It has to be shaded with both fractions. So remember the overlap between yellow and blue made green?
So then for the next one, it would be 2.
Yeah. Out of how many are all together? So the next
Well, then how do
one,
you get the one?
we can see that 2 are shaded, right? 2 out of what?
20.
2 out of 20 parts. Now everyone look at this fraction. What's 2 times 1? 2. What's 5 times 4? 20. Isn't that easy to multiply fractions straight across? What would 2/20ths reduced into simplest terms be? They both share what factor, boys and girls? A 2. So if I divide both the numerator and denominator by 2, I'm going to get 1/10. Which doesn't mean that the way that the model looks is wrong. It means if I were going to draw a model, 1 out of every 10 parts would be shaded with both. Wouldn't that be true? 1 out of every 10 parts. All right, number 4. How many are shaded double? How many are shaded with both colors? Zoe, how many? 4 out of how many parts altogether though? 9, yeah. 4 out of 9. So 4/9 is the answer. Can it be simplified at all? No, because 4 only has factors 2 and 2, and 9 has 3 and 3, and they don't share anything else with each other. So if they share nothing else but 1, you're done.
That's what it said.
Yeah. Oh, number 5 is not fraction of fraction, it's grouping. So how many groupings are there? There's 4 groupings of what fraction?
8.
Groupings of 3/8. So I would have to count up how many eighths. So each of these is worth 1/8. How many eighths are shaded all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 what? 12 eighths. Improper fractional words. How many times does 8 fit into 12? 1 full time, and 4/8 left over. Uh-oh, I know 4/8 can be reduced. 1 and 1/2. 1 and 1/2. What? 4 is half of 8, isn't it?
Yeah.
Is 4 half of 8? Then pull out a 4 out of both of them and not a 2. Pull a 4 out of both of them. Okay, just. Yep. Show me what you can do with number 6. Fraction of fraction. How many parts are double shaded out of how many parts? 1, 2, 3, 4. Okay, tell me the answer. 8 over 15. Now, everybody look at the fraction beside it. Does it match what we came up with? by using our eyes? Yes. The procedure should match. All right. Last couple here, fraction of fraction for number 7. How many are double shaded? Okay, but what do I put on the line? 3/12. They answered that for me. You're so smart. Do you see that? They answered that for you. So they want us to put what other fraction was 3/4 multiplied by to get 3/12. How can you see that here on the paper? Will, what do you see?
I have 4 of nothing. It's 4.
Am I able to talk yet? So 3/4 is represented by the lines or the solid part, boys and girls? 3/4 is represented by the lines. 3/4 is represented by the lines. And the shaded part, you can see on the other side, the shaded part, 1 out of the 3 sections is solid. So the fraction is 1/3. It's on your workbook. 1 out of the 3 sections is shaded. So it's 1/3. And when we multiply, 3 times 1 is 3. 4 times 3 is 12. We can see that our calculation ends up being proper and correct. They have a line next to 3/12 because 3/12 is not in simplest form, is it? What would 3 divided by 12 be?
1/4.
Yeah, it's 1/4. Good job.
1/4.
Number 8 looks identical to number 6. I don't know if you noticed that. So what fraction is making it function like that? The striped part is 2 out of 3, right? And the solid part is 4 out of 5. And what is the double shaded, the answer part, the product? 8 out of 15.
I can't see because you're screen.
All right, the last one here is showing groupings, right? Whole number groupings. How many groupings are there?
2.
There's 2 groupings, and each of those groupings has a name, right? What fraction is represented in number 9? 5 parts are colored by 6.
6, so then that's 12.
So that means if I multiply the 2 groups of 5, 6, how many 6 are colored all together? How many 6? 10 of them. 1, 2, 3, 4, 5 in this one, and 6, 7, 8, 9, 10 in the next one. 10, 6, improper fraction alert. It's 1 and 4, 6, but I reduced it to 1 and 2/3. I was running out of space. Oh my goodness. So for homework, I'm going to see if I can scoot down the page here. For your homework, you are only working on 1 through 6 on the next page. But for numbers 1, 2, 3, you are given a model and you have to write the fractions involved, their product. But then numbers 4, 5, and 6, you're drawing the model. So look at number 1. Is that a fraction of a fraction or is it whole number grouping? Okay, this one is fraction of fraction. So maybe label it for yourself, fraction of a fraction. And I know that because there's still only one whole here, one whole having 1, 2, 3, 4, 12 parts, right? A whole represents 12 parts, and I don't have 12 parts. So I know that my fraction is going to be a piece of a piece. Number 2 is also a fraction of a fraction. Number 3 looks way different, doesn't it? Number 3 is whole number groupings because there are little individual drawings that represent the same copy of the same fraction over and over again. So is number 4 whole number grouping or fraction of fraction? Yeah, good job. Whole number grouping because of this whole number right here that says make 4 copies of 7/8. Make 4 copies of it. So you have to draw 7/8 1 time, 2 times, 3 times, 4 times. And number 5 is whole number grouping. You're drawing 5 copies of 3/4. And number 6 is fraction of a fraction. So you're going to draw something that looks like this rectangle with overlapping parts, 5/6 going one direction, 1/2 going the other direction, okay? Yep, yep, 4, 5, and 6, you're drawing it and solving it. Okay, you have the rest of the class period here to work away at this. Use the models on 125 to help get you started, okay?
I will not start for a minute. Why did Michael Palaucha text from Detroit? That's what he said. He says, okay, I'll remember. Of course, why? Thank you. You should use 2 different colors or 2 different lines, solid. This is homework and this is independent practice. So I do want you, I'm sorry, I want you to struggle with it a little bit. I want you to wrestle with it. I don't want to tell you the answers. Because do you think true learning comes from me telling you the answer or you discovering the answer? It's you discovering the answer. So I'm sorry, sometimes I go like, no, figure it out, or no, try it again. I'm willing to coach, but I want you to dig through it a little bit. Anyone at home have any questions or want some support? How you doing? All right.